Hello friends, welcome to the new problem. This question is from 2019 CSAT paper. Again, we need to focus upon certain types of questions. There is a high possibility that these questions could be repeated in next year or this year CSAT paper. So let us start. Why I have chosen this question is basically because it is based upon prime number concept. So in order to tell you that there would be at least one question which will be based upon prime number system. So let us revise first prime numbers. We know that from 1 till 100 there are total 25 prime numbers, right? So these are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and this 525. So these are prime numbers, right? The prime numbers are only divisible by 1 or that number itself, and 2 is the only prime number which is even. So this is important thing, and these are important observation you keep in mind. Now let us start. So we have been given two sentences. So what are those two sentences? First, P and Q both are prime numbers. So P and Q can take values from these 25 prime numbers which I had just written. So S1 can be any numbers, any prime numbers. It can, and these prime numbers could be beyond 100 as well. Now P plus Q is an odd integer. Remember, 2, 3, 5, 7, 11, 13. Apart from 2, you just add up any two prime numbers. So 3 plus 5 is 8, 7 plus 5, 12. We know that you will find every prime number is odd apart from 2. 2 is the only prime number which is even, and we already know that odd plus odd is always even. So we know that either one of these two numbers, P or Q, has to be 2. Then only it is possible to get odd integer, because if one prime number is 2, then other prime number can be any prime number from rest of the prime numbers starting from 3 onwards. Now we know that these two are statements. So what has been asked is PQ an odd integer. So in order to satisfy both the statements, we can take P and Q as any P or Q, any number as 2 and any other prime number, let's say 3. So P and Q both are prime number. This is also satisfied for 2 and 3, that is for P and Q. And P plus Q is an odd integer, that is 2 plus 3 is 5. So that is an odd integer. Integer is nothing but, we know that, minus 1, minus 2, etc. onwards. 0, 1, 2, 3. These are the integer values. Now, is PQ an odd integer? So it is multiplication of P and Q. If P is 2 and Q is 3, then it will be 6. Right? So it will be 6. So 6 is not an odd integer. But that is not the question. What is the question? in order to determine whether PQ is an odd integer, whether one sentence or statement or both statements are necessary to arrive at the conclusion whether PQ is an odd integer. But you know that P and Q, if we take P and Q, then only single statement S1 statement cannot determine whether P and Q is PQ is an odd integer, because P and Q can take values from anywhere 2, 3, 5, 7, 11, etc. So in one case 2 and 3, if it is 2 and 3, so answer would be 6. But if it is 3 and 5, the answer would be 15. So only first statement cannot conclusively provide whether PQ is an odd integer. Now what is the second? P plus Q is an odd integer. In this case, we know that in order to get an addition which is an odd integer, one number from P and Q has to be 2. That is only possible when we take one prime number as even, and that is only possible in case of 2. So 2 should be there, and other can be any prime number. So it can be 5, 7, 11, 13, 17, 19. So in this case, we know that 2 plus 17 would be 19, which is odd integer, or 2 plus 7, 9 odd integer, 2 plus 11, 13 odd integer. So based on this, we know that if any number is multiplied by 2, it will result in sum. So even if we have statement S2, it is possible to determine whether PQ is an odd integer or not. Right. But which of the following is correct? We know that P plus Q is an odd integer. It can be possible. Let us consider that prime is not given here, or if we have not been given statement S1, then P plus Q is an odd integer. So what could be the possible combination? One has to be, some other has to be even. One has to be even, other has to be odd. So in this case, 5 plus 2 is 7, which is an odd integer, and 5 plus 4 is 9, which is also an odd integer. Now what is PQ? PQ is 10. This is also 20. Right. So in both cases, we are able to determine whether PQ is an odd integer or not. Now one would wonder that whether this criteria of prime number will only satisfy this, because in order to get odd integer, both has to be one of them has to be an odd number. So it will be always, one will be always odd. So as per my assessment, statement S2 is sufficient in order to arrive at the conclusion that PQ is an odd integer or not. So I would say statement S2 is alone sufficient to answer this question, this particular question. I hope you got idea. It is actually easy, but I wanted you to focus upon prime numbers as well. Though prime number concept is not that much related to this answer, because only S2 will satisfy your answer, but still I wanted to emphasize upon prime numbers concept so that you would get idea how actually this number 2, which is prime as well as even as well as prime number, that's an exception, because we know that all prime numbers are odd in first place. So that is one thing you keep in mind. There are 25 prime numbers, you also keep in mind, and you try to calculate these separately, and in order to arrive at a conclusion, you consider these two statements separately also, and if one statement separately is not able to give this conclusion, then we will say that another statement is also needed. So this is one way you can solve these questions. I hope you get some idea from these questions. I wish you all the best.